Welcome to my video on measuring household water pressure. Before I get into talking about the water pressure, what I want to do is give the definition of what water pressure is, or pressure in general. It's force per unit area. P is equal to the pressure. It's measured in units of PSI or kilopascal. The force is measured in units of Newton, and the area is going to be in units of meters squared. That's in the SI system. So our units of pressure we most commonly see in the United States is going to be the pounds per square inch, or the Pascal, which is 1 Newton per meter squared, force per unit area. Turns out the Pascal is a little small. We can multiply by 1,000 and get a kilopascal, or kP is a more common unit. Now to do our conversion between the two systems, the English and the SI system, if we know the number of PSI, we multiply by 6.89476, and that gives us the pressure in kilopascal. To go the opposite way, if we know the number of kilopascal, divide by this number to get the PSI. Now I want to show you a little video. This is at my house. I plugged a gauge directly in, and we're going to measure the water pressure. You can see I turned it on. It's a little hard to see because my hand was kind of in the way, but there's a big pressure spike, and then it goes down to around 105. So what we observed there is called a hydraulic shock, also known as a water hammer effect. Is a sudden surge in water pressure caused when flowing water is abruptly stopped or redirected, such as by quickly closing a valve or faucet. In water pressure gauges, this can appear as a brief pressure spike, often overshooting normal reading before settling out. It occurs due to a momentum of water and the compressibility of the piping system. Even though you think the pipes are rigid, they have a small amount of give, and this causes a pressure waves. Basically, it's the change in the water pressure suddenly. That's like when your house, when you turn on or off the water rapidly, you will hear the pipes rattle sometimes, and that's what that is. That's a water hammer or pressure shock effect. Now, in my case, it was 105 psi. I multiplied by 6.89, so my house has approximately 725 kilopascal, or 105 psi. Now, in this video, what I want to do is I've got a close-up of the gauge, and this time I added a water hose, like a 50-foot water hose, and I want to see things change. So let's watch the video and see what happens here. Okay, same water pressure. I turn on the hose. You can see the water pressure, the little black needle rises more slowly, and then the red needle actually measures the overshoot, and you can see it doesn't. It's kind of a little hard to see because of the sun's glare on the gauge. But if you look closely, you can kind of see the red, which is your maximum, and then, okay, there it goes. It's about 104 again, 105. And so I turn it off, and the water pressure drips off slowly, or lowers slowly. That's due to the leak. Got a leak in the system, and as the air escapes. So let's look at that in more detail. Why the slow rise in pressure and the lack of hydraulic shock? When I attached the 50-foot hose and turned on the water, the pressure rose more slowly with little overshoot because the hose acted like a shock absorber. Its flexible walls expanded slightly as pressure built up, absorbing some of the initial water surge. This lowered the pressure rise and reduced the water hammer effect. In contrast, a rigid system, like a short pipe, has less give or expandability, so pressure spikes appear more quickly with greater overshoot on the gauge. And so that's just what we observed, that the water pipe acted as a shock absorber and the water pressure rose more slowly. So what kind of conclusions can we get out of this? A pressure spike is observed when the valve is first turned on. It's called a water hammer effect, or a hydraulic shock, due to the momentum of the water and the pressure wave moving throughout the system. The second thing we observe is when a hose is added before the gauge, the hose acts as a shock absorber and eliminates the pressure spike. And the third thing, which is probably more relevant to me, is the water pressure at my house is very high, 105 psi. I probably need to get a water pressure reducer, but I'm not going to because I've lived in this house several years. There's no leaks, so I guess it's working. In the United States, the typical range is 40 to 80 psi, and the optimal is 50 to 60 psi. And obviously, it can handle more, typical plumbing, and then the maximum is recommended is about 80 psi, so I exceed that. Well, I hope you got something out of this video, learn a little bit about measuring water pressure in a house. If you did, give me a like, thumbs up, subscribe to my channel. Thank you for watching.